In this lecture video, I will be covering first order nonlinear differential equation, specifically the Bernoulli equation. That is an equation of the form y prime plus p of x into y is equal to q of x into y power n. This equation is called the Bernoulli's equation. So is nonlinear. This is nonlinear differential equation. The nonlinearity is because of y power n. So the only condition is that n is not equal to 1. There is a reason for it. We will see further why n is not equal to 1 is necessary. So this type of differential equations are nonlinear first order differential equations, and these equations we are converting. We are going to convert into a first order linear differential equation. So with a transformation, we will see what is the transformation now and how to convert that given differential equation, nonlinear differential equation, to linear. And further we are using, after conversion, we are using integrating factor techniques to find the solution to the differential equation. Let's see the solution procedure. So if I multiply this throughout the equation with y power minus n, then I will be having plus p of x into y power minus n q of x into y power n minus n. That is, you can rewrite this equation as y power minus n dy by dx plus p of x into y power 1 minus n, which is equal to q of x. So this is actually playing a crucial role. You know that the moment when you apply derivative over this is becoming 1 minus n times y power 1 minus n minus 1, which is equal to, and of course dy by dx, which is equal to y power minus n dy by dx. You see, this is exactly same as this one. Of course, there is 1 minus n in the form of multiplication. Therefore, I am going to assume that let my v is equal to y power 1 minus n. Therefore, after applying derivative dv by dx, which is equal to 1 minus n into y power 1 minus n minus 1 dy by dx. Further simplification leads to y power minus n is equal dy by dx is equal to 1 by 1 minus n dv by dx. Now you replace this term in the given differential equation with the new variable, that is 1 minus n dv by dx plus p of x into y power 1 minus n, but y power 1 minus n is nothing but v, which is equal to q of x. This is your new equation, and you can further simplify by taking cross multiplication, or you can leave just like that. It doesn't matter. So you have to adjust those terms. Let me start. Let me take one example. So solve the example. Solve the following differential equation. What is that? This is dy by dx plus 4 by x times y, which is equal to x cube into y square, and this is the differential equation. What is the solution? Solution to this is, so we have to start with let v is equal to y power 1 minus n. Of course, if you want to compare where n is equal to 2 in this case, we have seen that dv by dx into 1 by 1 minus n must be equal to y power minus n dy by dx. So that is, if you rewrite this equation, y power minus 2 dy by dx plus 4 by x into y power 1 minus 2, which is equal to, now you can compare what is p, what is q and other values. That gives you n is equal to 2. Here n is equal to 2. We have seen already n is equal to 2. Therefore, y power minus 2 dy by dx is equal to 1 by 1 minus 2 dv by dx. That is minus dv by dx is the replacement of y power minus 2 dy by dx. Therefore, if you replace, you will be getting minus dv by dx plus 4 by x into v, which is equal to x cube. This is your new form. If you want to retain, you can keep this. Otherwise, you can rewrite it as minus 4 by xv, which is equal to minus x cube. This is new. This is a differential equation of dv by dx plus p of x into v, which is equal to q of x form. Now, integrating factor is equal to e power integral minus 4 by x dx, that is equal to e power 4 times minus 4 times 1 by x dx, which is equal to x power minus 4. That is the output of this. This you can get it by e power minus 4 log x, that implies x power minus 4. Now, this is your integrating factor. Therefore, v into integrating factor is equal to integration of integrating factor into q of x dx plus c is your solution. Therefore, it is v times x power minus 4, which is equal to integral x power minus 4, and q is x cube dx plus c. So, this implies v into x power minus 4, which is equal to x power minus 1 dx plus c. This is equal to, if you want to write it, you can write it ln of x plus c. Therefore, v is equal to x power 4 into ln of absolute value of x plus c into x power 4. And further, if you want to simplify, you can write it, what is the value of v? V is equal to y power, v is equal to y power 1 minus n, but n is 2. That implies y power minus 2 is equal to x power 4 ln of x plus c. Oh, sorry, this is minus 1. 1 minus, when n is 2, y power 1 minus 2 is y power minus 1. Y power minus 1 is x power 4 ln of x plus c of x. That's your solution. Oh, so there is minus here, right? There is minus, therefore it must be minus x cube minus and minus, and then this is minus. That is y power minus 1 is equal to cx minus x power 4 ln of x is the solution to the given problem, given differential equation. So let me solve one more problem on the same method, Bernoulli differential equation. So let's take a simple example. Example 2. Example 2 is dy by dx plus y by x is equal to y cube. So now you have to solve this differential equation. So if you bring this term to the left hand side, that is y power minus 3 dy by dx plus 1 by x into y power minus 3, which is equal to 1, that is y power minus 3 dy by dx plus 1 by x into y power 1 minus 3, which is equal to 1. Now let v is equal to y power 1 minus 3, that is y power minus 2, implies dv by dx is equal to y power minus 2 minus 1 into minus 2 dy by dx, that is equal to minus 2 times y power minus 3 dy by dx. Of course, we have seen already d 1 by 1 minus n into dv by dx, that is minus 1 by 2 dv by dx is y power minus 3 dy by dx. Therefore, in the given equation, this term, I mean this one we are replacing, that gives you minus 1 by 2 dv by dx plus 1 by x, y power 1 minus 3 is nothing but v is equal to 1. If you further simplify dv by dx, minus 2 by x into v, which is equal to minus 2. It is the new form where integrating factor is equal to e power this term, that is e power minus 2 by x dx, that is e power minus 2 integration of 1 by x dx, which is equal to e power log x power minus 2, which implies x power minus 2 is the integrating factor. Once you get x power minus 2 is the integrating factor, v into integrating factor is equal to integration of integrating factor into q of x dx plus c. So that is v into x power minus 2 is equal to x power minus 2 into q of x is minus 2 in this case dx plus c. That implies v x power minus 2 minus 2 divided by x power minus 2 plus 1 divided by minus 2 plus 1 plus c. That implies we have minus v into x power minus 2, which is equal to 2 times x power minus 1 plus c. Therefore, v is equal to 2 into x power 1 plus c into x power plus 2. So, now substitute v is equal to y power 1 minus 3, that is y power minus 2. Therefore, y power minus 2 is equal to 2x plus cx square is the solution. If you want to rewrite it, you can write it. You can bring y power minus 2 to the right hand side, that is y square if you bring, and you bring this term to the left hand side, that is 1 by 2x plus cx square. That is your solution to the equation. And if you want to study any problem with initial conditions, we can add, that is the data is defined at particular position, therefore you can fix the constant c. So let's take one more problem with initial inputs. So that is your solve the following initial value problem. And that is 6 into y prime minus 2y, which is equal to x into y power 4, and y0 is equal to minus 2. That is, when x equal to 0, y starts at minus 2. So therefore, this is the input. So solution is, you are rewriting the given equation as 1 by y power 4 and 6 y prime minus 2 y into y power minus 4, which is equal to x. If you want 6, you can bring it to the right hand side, or let it be there for time being. Y power minus 4 and then y prime minus 2 y power 1 minus 4 is equal to x. We are assuming let v is equal to y power 1 minus n, where n is equal to 4 here. Therefore, 1 by n 1 minus n dv by dx is the replacement for y power minus n dy by dx. Since n is 4 here, y power minus 4 dy by dx must be equal to 1 by 1 minus 4 into dv by dx, which is equal to minus 1 by 3 dv by dx. Now, if you substitute 6 times minus 1 by 3 dv by dx plus minus 2y times, minus 2 into v, which is equal to x, Now, further if you try to simplify dv by dx, so this is something like you can simplify, this is 1 ja, this is 2 ja, therefore we can further simplify. further simplify with minus sign, therefore this is plus 2v divided by 2 and minus x by 2. So this is dv by dx plus v, which is equal to minus x by 2. Now if we take integrating factor is equal to e power, this is only 1 is there, 1 into dx, which is equal to e power x. Therefore v into integrating factor is equal to integration of integrating factor into q of x dx plus c, that is v into integrating factor is e power x, which is equal to e power x into minus x by 2 dx plus c. So here you need to simplify using bipartition. So by parts, integration by parts, that is minus x by 2 into e power minus integration minus 1 by 2 into e power x dx, which is further can be reduced to minus x by 2 e power x, and this is plus e power x by 2, which is equal to 1 by 2 times e power x into 1 minus x is the output. If you substitute v e power x is equal to e power x by 2 into 1 minus x plus c, and further if you try to bring this right hand side and replace v by y power 1 minus n, that is n is equal to 4, 1 minus 4, which is equal to 1 by 2 into 1 minus x plus c power minus x. Further you can say that y power minus 3 is equal to 1 by 2 into 1 minus x plus c power minus x. But we have some more information, that is initial value problem. This is the initial value problem where when x is 0, y is minus 2. That is when x is 0, when x is 0, y is minus 2. Therefore, this is y power minus 3 is 1 by y cube, which is equal to 1 by 2 into 1 minus x plus c power minus x. At x equal to 0, y is like minus 2. Therefore, minus 2 whole cube is equal to 1 by 2 into 1 minus 0 plus c power minus 0. That implies this is minus 1 by 8 is equal to 1 by 2 plus c e power 0 is 1. Therefore, c is equal to 1 by 2 minus 1 by 8, which is equal to 3 by 8 here. Therefore, this is minus 5 by 8, sorry, minus 5 by 8. This is minus 5 by 8, and therefore y of x is equal to 1 by y cube is equal to 1 by 2 into 1 minus x minus 5 by 8 into e power minus x. If you want, you can stop here. Otherwise, you take the cross multiplication and then try to simplify. That gives you your solution is something like y of x is equal to 2 divided by 4x minus 4 plus 5 e power minus x whole power 1 by 3. So this is your solution to the given differential equation. If you follow the video, please like the video and subscribe the channel for more updates. Thank you.